Yeah.
Okay. Thanks, Jean, for the introduction. Let me share the screen. Okay, can you see correctly the screen?
Yes, very good.
Okay, so I will start. We will present the Infrastructure Manager service. It's a TOSCA-based cloud orchestrator and deployment tool that is integrated in the EGI ecosystem and is part of the set of the services provided by the EGI system. I will start with an introduction talking about the infrastructure as a code. Because in the past, when the sysadmin needs to configure and deploy an infrastructure, most of the work must be done manually. So we have to configure a server, create the network, configure the software, and it's doing all these things manually. It's easy to provide errors. It's easy to have misconfigurations. It's slow. And it's very difficult to reproduce the same configuration in different platforms. And this is why appears the DevOps tools, and in particular, the paradigm of the infrastructure as a code. As we are commenting, the infrastructure as a code is a process for managing and provision competing data centers using machine-readable definition files. In this way, you can specify all your requirements in a document, and this can be translated into a final real deployment of your virtual infrastructure or set of applications. Using this paradigm, you can automate the entire processing and deployment process of your infrastructure, which makes the process more faster and more reliable than using any kind of manual process. You can store these files as in any kind of version control tool, so you have a history of the different steps of the evolution of your infrastructure. And in case of you have a problem, you can debug easily, and if necessary, you can roll back to another version that in the past was working. You can also validate each infrastructure change in these readable documents using some kind of reviews or automated tests. And you can also use a set of libraries of reusable documents where you can isolate some part of the configuration. Currently, there are several tools that perform this infrastructure as a code paradigm, as Ansible, Puppet, Chef, Terraform, CloudFormation, etc. We will focus in Ansible because it is the tool that we have selected to use in the infrastructure manager. So the infrastructure manager uses this principle, this infrastructure as a code paradigm, to automate the deployment of virtual infrastructures on top of cloud resources. So using the IAM tool, you can automate the entire provision deployment process of any kind of virtual infrastructure. You can use the same definition templates to provision your virtual infrastructure in different cloud providers, either on premises or either public. You can use the Oasis Tosca simple YAML profile standard to describe your topologies. And we have commented you can store these files in version control system in order to have your entire history in order to control the evolution of your infrastructure. So what is the infrastructure manager? It is a service that enables the user the deployment of virtual infrastructure on top of cloud resources. It uses two different languages to describe the infrastructure using this infrastructure as a code paradigm, the RADL and TOSCA. RADL is the native language of the infrastructure manager, and after the creation of the infrastructure manager, we adopted also the TOSCA standard. In next slide, we will show some examples of both languages. And the IAM then automates the deployment, configuration, software installation, monitoring, etc. of the virtual infrastructure. And it supports a wide variety of cloud backends, thus making the applications cloud agnostic. So, as we have commented, you can use the very same description to deploy the very same infrastructure in different cloud providers. So in a general view, the infrastructure manager enables to deploy customizable virtual computing infrastructures with the precise software configuration required by the user. It allows to deploy any kind of complex infrastructure, even deploying different set of virtual machines in different cloud providers. And we are using this infrastructure as a code paradigm. It enables to share the infrastructure descriptions. It does not need to use any prepackaged virtual machines because there are another components that require some kind of agents to be pre-installed in the virtual machine images. In the case of the IAM, you can use any virtual machine image that you have in your cloud provider. And all these features enable that the same complex infrastructure can be deployed both on-premise or in a public cloud provider. So the main IAM features, as it features DevOps capabilities, because it is based on Ansible. It provides a set of recipes for common deployments. And it also supports Cloud Init scripts for some special use cases, but in most of the cases, we use Ansible to describe the installation procedures for any of the platforms. The IAM works as a service that offers several interfaces. It offers two APIs. The main one is the REST API. And it also offers two client applications. One is the command line applications, and the other one is a web-based graphical user interface. That is the IAM dashboard. That is the main tool that we will show in the demo part at the end of this presentation. And it is distributed using the GPL license, so it's source code, and it's available in GitHub, all the code. As we have commented, it supports a wide range of cloud providers. In the case of public providers, it provides the most used providers currently as the AWS, Google Cloud, Azure, but another platform to support that Linode. It supports European providers as OTC, Cloud-agnostic, Orange Cloud. In case of on-premises platforms, it supports OpenNebula, OpenStack, CloudStack, and VMware. In the case of federated platforms, it supports EGI Cloud Compute, of course. It then also supports Bow, but it also enables to deploy containers on top of some container management platforms, as it is Docker or Kubernetes. And it is designed in a plugin using a system of plugins, so it can be easily extended to add new cloud providers. So the IAM working scheme is the user provide the infrastructure description using RADL or TOSCA. It is processed by the IAM, goes to the deployment of the virtual resources, and then go to the configure part. The two languages is the RADL that comes from Resource and Application Description Language. That is a high-level language to define virtual infrastructure and specify virtual machine requirements. As we have commented, this is the first language, the native language that was created when the IAM was initially developed. And after the creation of the TOSCA standard by OASIS, we also adopted it in order to enable the description of the topologies using this standard. I will show a bit how this different language works. In the case of an RADL, it has several keywords. And the most common ones are for example, the network, in order to define the different networks used before your application. The system keyword that is used to define the different set of virtual machines that you want to deploy. Configure and contextualize, that is used to define how your application will be installed and configured in the set of virtual machines that will be deployed. And finally, the deploy keyword that specifies the number of virtual machines that will be deployed. But it will be easier showing an example. For example, in this case, we are using a simple definition of one virtual machine, that it is connected to a network that has outbound connectivity. So it means that it will have a public IP connected. It has a system that we call node, that one CPU that have at least half gigabyte of RAM, and it is connected to this network that we have defined. In the configuration section, we have this code that is part of the Ansible language. So in this case, we are specifying that we are going to create one user with this password. But in this case, any Ansible playbook can be added here. And finally, we say that we will deploy in one virtual machine of this type. And in the case of TOSCA, it's an OASIS standard. It uses the YAML language. It's a standard to specify cloud topologies. And it's supposed to enable portability and management across different cloud providers. Let's see an example. As any standard, the language of OASIS is a bit more complicated. You have an initial import section where you have what is called custom types, because TOSCA defines a set of normative types that are part of this standard, but it enables you to extend this set of normative type, adding your own custom types. So we are importing here these custom types. In particular, we are creating this node type that we will use later. We have an initial part of inputs where the user can set any parameter that will be used then in the definition of the topology. In this case, we are only setting the memory size where the user can specify, but in this case, the default value is 1 gigabyte. Then we are defining the deployment of the Kepler software, that this is one of the nodes that are defined in the custom types because it's not a standard one. And we are saying that it's deployed in this server, in the Kepler server, which is the host. And this is a compute where we are saying that it requires a public network, that it exposes a port, in this case, a BNC port. And it requires one CPU, and it gets the memory from the input value that we have specified at the beginning. Finally, we also specify the properties of the infrastructure, the operating system, and we require an Ubuntu 18 in this case. Finally, the TOSCA also enables to specify a set of outputs that are the set of values that the user will require to connect our application. In this particular case, we are returning to the user the instance IP and the instance credit, that it is basically the set of SSH credentials required to access the virtual machine. So after the definition, the infrastructure manager starts the deployment of the set of cloud resources that are required, the network, the virtual machines, the volumes, security groups, etc. And once all these set of cloud resources are configured, it starts the contextualization process. As we have commented, it uses Ansible, and this process requires that at least one of the virtual machines of the deployment has a Linux-based machine with a public IP. And this The virtual machine is configured. It is marked, let's say, as the master VM. And the infrastructure manager configures Ansible from the IAM and then uses this virtual machine in order to configure the rest of the virtual machines of the infrastructure. As commented, there are different client tools, in particular the command line one, that is the IAM client, that it is also it provides also a software development kit for Python applications. And the graphical interface, mainly the IAM dashboard, that it is publicly available. It's available in the web im.egi.eu. You can access it. You only need to log in with the EGI check-in. It is integrated with AppDB in order to get information about the EGI Cloud Compute sites and images available for each of the sites. It enables to deploy infrastructure from a web browser using a set of curated TOSCA templates using, as we will show later, a wizard-like composition of TOSCA templates. So it uses an easy interface. It is for non-advanced users in a way that only a set of clicks you have the ability to deploy, for example, a Kubernetes cluster. You don't need to have to know anything about TOSCA or anything about the internals of the infrastructure manager, but it finally uses TOSCA in order to make the deployment. It also provides a set of APIs consumed by the clients. One of the APIs is the current most used one is the REST API. It follows the OpenAPI specification, and you have more information in these two links. And you have this SwaggerHub information about the infrastructure manager to get all this information of how to create a client, to get access to the API. This is the IAM architecture. I will not enter into much detail in the internals of the IAM. I only want to show some of the tools that we are using, let's say, in the IAM ecosystem. One of the tools that is CLUS, that is also one of the developments of our group, that is an elasticity manager, that it enables to trigger the addition and removal of nodes in virtual clusters, that it supports several backends, for example, Kubernetes, SLURM, etc. In case of the IAM dashboard, we use Vault to securely store the credentials. And it can be also configured in the IAM to get the credentials directly instead of passing through the IAM dashboard. We commented Ansible for the contextualization, AppDB to get the EGI sites information and virtual machine images. And in the last months, we also have added cloud continuous support in order to enable the IAM to manage devices at the edge. In this case, we have done it using Oscar. That is one of the tools also for the developed in our group that enables to create functions as a service. And the IAM also enables to deploy containers directly in Kubernetes clusters. So now let's move. I will show a video with a demo of the infrastructure manager, because sometimes it's better to see how the system works. In this case, we will show how to use the IAM dashboard to deploy a Kubernetes cluster with JupyterHub, also using a set of working nodes with different features. I will have commented first of all, we need to access using the EGI credentials. Then we have here the set of different templates that the user can deploy. And in this particular case, we will launch the Kubernetes cluster. But first of all, we go to the cloud providers section. In this case, you can see that we have a large set of cloud providers. For example, we have AWS, Azure, cloud-agnostic, Google Cloud, one OpenStack site that this is part of UPV, or an EGI site. And in the demo now, we will show how to create and how to add new cloud credential. For example, in this case, we'll show how to add a cloud credential for an EGI site. In this case, we only have to select the PO. It automatically gets the list of sites from AppDB. So you have to click on add, and it is added to the list of cloud providers. Another interesting feature is the addition of SSH keys. In this case, you only have to add a description, copy your SSH public key, and it will be automatically inserted in all the virtual machines that you deploy in a way that is easy to access these virtual machines later. So now we start to create the deployment. We have selected the Kubernetes deployment, and we will go to this second step of the wizard, where we can add several tools on top of this Kubernetes cluster. In this particular case, we will launch JupyterHub on top of the Kubernetes, and we also select this feature in order to add a working node with different features in a way that we will create an heterogeneous Kubernetes cluster where one of the set of working nodes will have a GPU. Then when we have selected the set of templates to deploy, we have this input section that it is basically rendering the input part of the TOSCA template that we have shown in the previous slide. So we set a name for the infrastructure. We can specify the features of the front-end node. Then we can set the number and the features of the first set of worker nodes. In this case, we don't set any special requirement. We leave the default ones. In the next tab, we set the different features of Kubernetes that it is the several parameters that enable us to tune the Kubernetes installation, but with not much detail that enables the non-advanced users to make the deployment easy. In this particular case, we will set to install the third manager in order to get valid TSL certificates. In this demo, we also will show how to integrate this functionality with the dynamic DNS service provided also by EGI. So we will use this DNS name, this JupyterHub test.cloud.eu. But in order to use it, we will register this name using the DNS service. So we set the name, we select the domain, and once it has been created, we get the name, and we can use it in our infrastructure. We will see later that we only need to update the IP. We also have some parameters of the JupyterHub. And finally, we have also the second working node feature. So we will, in this case, we will only deploy one. We have increased the amount of CPUs of RAM in this case, and we will set that we want a GPU, and we also add the flag to support the NVIDIA drivers. In this case, we will install the NVIDIA drivers and configure everything that enables the user to have access from Kubernetes to the GPUs. Finally, we will select the cloud provider. In this case, we will use the cloud provider of that is internal from UPP. That is because this is the one that we are sure that we have access to GPUs. We select the virtual machine image, and in this case, we have selected an Ubuntu 22, and then it starts the deployment process. As we have commented, initially it starts creating the set of virtual machines, the network, the security groups, and columns, etc., and then starts the configuration process using Ansible tool. We can see that all the VMs are running, and now we will get the information of the first virtual machine. That is the one with the public IP. We will use it in order to update the DNS entry in the DNS service. Now we have updated the DNS service in a way that we can access our virtual machine using this name. And this will enable us to have a valid TLS certificate. Once it is configured, we can see this output section, and we have shown in the previous TOSCA example. These are the set of DNS endpoints. We can see one of the JupyterHub, another for the Kubernetes dashboard, and we will see how to access the virtual machine using the different interfaces. For example, using the JupyterHub. Well, in this case, we will start accessing the Kubernetes dashboard in order to see that it is fully configured. And we can see the set of nodes that we have deployed. We have the front end, 2 working nodes. We can also access the front end using SSH. As we have commented, as I have added my SSH key into the IAM dashboard, it is automatically injected. So in a way that we have direct access to the virtual machine without any requirement about creating a new secret key or adding a password. Now we are only showing that we can get the information about the nodes. And in particular, we are showing here that the NVIDIA GPU is configured and is available from Kubernetes. So it enables us to deploy any Kubernetes application that have access to GPUs. And in particular, we will use JupyterHub in order to create a Jupyter notebook that have access to this GPU. And we will use an example application in order to show that the GPUs are available. In the part of the application, we see this server option. We will select the last one, that is the one that has one GPU available. As we have requested one GPU, this pod of Kubernetes will be deployed in the second working node. That is the only one that has GPU. So we can see that the Jupyter notebook is deployed there. And then I will use some Alzheimer application that use a set of artificial intelligence application in order to get some details about the Alzheimer application. I don't have too much details about the application, so I will skip this part. It was only done in order to show that the application have access to the GPUs. So we'll skip a bit this part. And you can see that finally the application made the calculations, and it gets the render of the brain images in order to get information about the Alzheimer SMR cases. So finally, once you have finished with our computation and you don't need your infrastructure in order to release the resources and to release, in case of using a public cloud, to avoid unnecessary costs, you can deploy it, and it will delete all the cloud resources that have been created for this virtual infrastructure. And this is the final of the demo. I hope that you. Okay. Let me. I cannot. Okay. Okay. So once you have seen the demo, I hope that it will make clearer how the IAM works. If not, then you can ask questions at the end. But we will also comment that the IAM is evolving for a long time. It was initially developed in a national Spanish project named For the Cloud, and it has been extended with several features in different players. We can specifically comment the Indigo Data Cloud, where the extension of supporting TOSCA has been added. It has been included in several European projects. Currently, in the project that we are now using it, is mainly creating and helping the use cases in order to create TOSCA templates to deploy in particular use cases. Currently, we are also starting the EOS Beyond project, which is the IAM is also part of it. And we are also starting the EOS procurement, where the infrastructure manager is part of the Lot 1 services. Now we will show a bit, we will comment a bit some European projects where the IAM is used and why it is used. We will comment, for example, the Experience project that has been recently finalized, where the infrastructure manager is used to deploy virtual infrastructure for the execution of AI model along the cloud computing continuum, enables to deploying function as a service on edge devices. In the case of DTGO project, the IAM is used to deploy SLURM clusters, customized in a way that enables the user, that the scientist, to train the computer skills before the execution of these same applications in a supercomputing, for example, in Mare Nostrum. So it enables the IAM enable the creation an SLURM cluster that is quite similar to the Mare Nostrum, in order that the user enables to train there without using these resources. We are also part of the InterTwin project, where it is used to deploy big data analytic tools to be used for digital twins. For example, we use it to deploy MLflow, Airflow, Kubeflow, Horobot, Galaxy, etc. And it is also part of the AI for EOS project, where it enables to deploy pre-trained AI models from the AI for EOS marketplace in several cloud platforms. And this is basically all for my part. So if you want more information, you can access the IAM webpage. We have a YouTube channel, and where there are several demos of how to use the IAM. And we have commented it is open source, so you can see the source code in GitHub, not only for the IAM service, but also for the dashboard. And the images are available to deploy the service in DockerHub and in also GitHub container registry. And this is all for my part. If you you want to contact, you can contact me. This is my email, and Germán Montó, my colleague, where you can get also his email in this slide. So we have finalized. So Jean, I don't know if we are going to the answer some questions.
Thank you very much, Miguel. Thank you. And probably we can stop the recording here. Federico, what do you think? And yes, very, very impressive. This very successful project, over 10 years development, is always keeping at the most advanced status and taking the developing new feature over time and catching up all the new rising technology. Very impressive. We have one well, in the Curie box, we have two question now. Martin, and I can enable you to talk. And he asked, do you need to enter your own cloud account? Martin, I can enable you to talk.
Yeah, well, I can start answering, and if you have any other issues, you can speak. As we have shown at the beginning, you have to add your own cloud accounts. For example, in the case of you are using EGI Cloud Compute, as we are facing AppDB, we have this way of getting information in a way that you only have to specify the PO, and it will get the list of sites. But in case you want to access your own OpenStack or your own AWS account, you have to add your cloud accounts in this cloud provider section in order to be able to deploy it there. I don't know if it answered your question.
Actually, he said the question already answered in the demo. Sorry about that. And I couldn't enable people to speak. Sorry about that. And you have to type your question in the Q&A box. Any question to Miguel? Sorry for inconvenience of this. Probably you can, if you raise your hand, whether I can. Oh yes, I can allow you to talk now. Yes, Martin again. Now I can make you talk.
Yes.
Yes.
Oh, I'm not sure how to activate my camera, but this will work, I guess. I'm Martin Brands from Surf. My question is, if you want to add OpenStack account, for example, do you need some special configuration on OpenStack side? Does the account need special privileges or certain images available? And the same for other clouds?
No, we have commented you don't need any special requirement. You only need a typical OpenStack user. You specify the user, the password, tenant, and any other standard OpenStack data. It does not require any admin privileges, and it doesn't require any special virtual machine HMA. So you can have this kind of vanilla images of an Ubuntu or CentOS or Rocky Linux or something like that, and it is enough. You don't require any special user, any special administrative user, or any special virtual machine image.
Okay, so the images come from Tosca and IM then?
No. The images come from the list of available images that are provided by the cloud site.
Yeah, okay. So, yeah, clear. Yeah. Thank you.
Thank you, Martin. Any other questions to Miguel? It's very good opportunity to directly talk to me, Miguel. No questions. So, okay. We still.
Yeah, I will always show because maybe it has not been clear in the demo. So I will show this only a bit. For example, when you want to deploy anything, in this particular case, I will select only a virtual machine. When you specify the cloud provider in this final section, for example, well, I will use this one that is our own cloud provider. Here you will get this list of virtual machine images that are available in the site. This is all the virtual machine images that we have in our cloud provider. And then you can use any of them to make the deployment. In the demo, we have used the Ubuntu 22, but in this case, for example, I can use this CentOS or this Ubuntu 24 or any other virtual machine that is provided by the cloud provider. And if I can move this, okay. In the part of cloud credentials, in case you want to add an OpenStack site, you only have to add to put here a specific name. Here you specify username, password, and tenant. And in some particular cases, you may need a domain, but in some cases you don't require, or region. And the host, that basically is for example, is the keystone URL, but you don't require any special administrative access or anything additional. This is only to clarify the previous questions.
Mm-hmm. Is it more clear, Martin? Is it good for you?
Yes, definitely. I also see some other very interesting things like the usage resource, site usage resource. Site resource usage from the OpenStack. So, but I will dive into the code and look how everything is set up.
Mm-hmm.
Thank you. Very nice.
Thank you, Martin.
Thank
Indeed,
you.
very nice. Any question from our audience? Actually, I have a very naive question. For all this configuration, if I missed any information there, what will happen? I have to have all this information at hand to deploy the service, or
what information?
And the configuration, filling up all this.
Most of the input values has always a default value that makes that the deployment works. So in most of the cases, if you don't touch anything, you will get a deployment that works. So this is the idea, that you only need to touch anything that you know that you are touching. For example, in most of the cases, you only need to change the amount of CPUs or the amount of RAM of the virtual machines, but probably the Kubernetes internals, maybe you don't need to touch it. So if you leave the default values, it will work.
Perfect. That's a very good for a user like me. Okay, I do not see any other question. No hands up. Okay, probably with this, we can close today's webinar. Thanks very much for Miguel for this excellent talk. Also, thanks very much for the dedication for this service. It's an excellent work. Thank you, Miguel. Also, thanks all today's audience. Thanks for Federico for your kind support. And the recording and presentation will follow up and will inform everyone.